Welcome back, everyone. I hope you enjoyed the break and are ready for our next session. It's going to be presented by Colin Chen, Executive Director at JP Morgan Chase. Colin will discuss the developments of data science on risk management and how data science also introduces new risks into risk management, either as complex procedures or well-defined models. Thanks for being with us, Colin. Take it away.
Hello, everyone. Let me introduce myself briefly. My name is Colin Chen. Currently, I'm working for my own consulting firm, Data Science and Analytics Consultants, which focus on the financial industry and the media industry. So for today's talk, I'm going to be present some applications of data science in the financial industry, especially in the risk management fields. And then I'm going to be underlying some of the challenges, and especially with the regulation and regulatory stuff, and then propose some solutions, potential solutions, and just hopefully show what's the trend and directions of data science applications in the risk management fields. First, I would like to giving this is my favorite slides across 250 years. History of industry revolutions. Everyone knows the first industry revolution starts from the middle of 18th century. The mark of that is steam power. My old school is Purdue University. Its nickname is Boilermaker. So it's founded. Purdue is founded right after the first industry revolution, before the second industry revolution. The second industry revolution started about 100 years later from the first one. The mark of that is the electricity, then into the 20th century, into the third industrial revolution, as on the, information era. The mark of that is the computer and internet. Now, where people are talking about, we are in the fourth industrial revolution, and some people call it 3.5. It's maybe it's not so important, but the important is what's the contents, what's inside this fourth industrial revolution. And clearly, people seems like they have a common concept is that data science, AI, machine learning should be a component of this fourth industrial revolution. There are other, high level, high technologies like, quantum computing, etc. But data science and machine learning and AI, it seems like it should be one component of this industrial revolution. So, what is data science? I think that currently the definition of data science is still it's a little bit not so clear. And there's the one from the literature. It's an informal one. It says the study of extracting useful information from data. I myself, feel the word useful is a little bit too flexible. Anything could be useful, right? So that, makes the definition is a little bit not so, formal. So what I recommend is using more scientific words like insightful. The study of extracting insightful information from data. So that's just, a little bit of my opinion. So the big mark of, data science, data is been there a long time. Statisticians study data, find insights from data a long time ago, over 100 years ago. But the data science words, what's new in data science, it's actually the big data and the significant, smart applications of big data. I think that's the new era of, data science, besides of the classical statistical analysis with data. So that's a little bit small, background for data science. So then let's talk about risk management. Risk management is a big field for the, financial industry. For, financial industry, there's two big functions. One is making money, right? For all the investment and retail, wholesale, banking, that's the, function, making money, get the revenue in. The second very significant function is, control the loss. So over the years and people, for these layers, there are big three tiers of risk people identified, market risk, credit risk, operation risk. And some newer tiers like liquidity risk, reputational risk, and others, they are a little bit newer. And data science started to, touch those new areas, and just started. But I'm going to be focused on the, first the three big layers of risks. Market risk, how data science being implemented in market risk and used in market risk. It's already, used in a great fashion, in market risk. So I don't know if you heard that, a robot risk management, robot asset management, or robot asset manager. So there's already there, and robust, there's a machine learning and AI algorithm based investment, smart investment strategy algorithms. So that's for the market risk. For credit risk, so for example, one example, a very significant implement of, AI and machine learning, AI algorithm and machine learning model is for underwriting, credit underwriting. And the people started using machine learning AI algorithms on underwriting in their underwriting system. It's not for because of regulation, not for the big banks. The big banks have not started this yet. They are using machine learning AI as an assistant, as some kind of assistant for underwriting. It's the fintech firms. They already started using AI and machine learning algorithms on underwriting in a great scale. I don't know if you heard that the PPP loans, the third largest, PPP loan distributor or underwriter is from a fintech. It's beat Wells Fargo, it's beat other big firms, PNC firms. So this kind of thing actually causing the regulator started to look at the risk of using AI machine learning stuff in risk management like underwriting. The one I said a couple of weeks ago, House Committee on Financial Services had hearing. The hearing called the testimony title, the name of the testimony called Equitable Algorithms. So the participants expressed various kind of concerns on using machine learning and AI algorithms on underwriting by these fintechs. It can do good and it also can do bad. It can do good because it can identify not served, underserved sectors, for credit. If it can do bad, it can actually produce a bias, for very good, profitable, groups, identify groups, with high profitable, but ignoring the, protected variables, which prohibited to be used in underwriting, like sex, religion, sex, and, age variables. And there's one dispute. There's one argument that third-party vendor using machine learning and AI underwriting using educational background, educational level. So that's a huge argument because the educational level could be highly correlated with those protected variables like, sex and, aging, and also, race, especially with race. So this is a very concerned by the regulator. That's something is still going on. So how you control the risk of using that in credit risk, it's under discussing. So in my talk, I give you more focus on operational risk because this is a much broader risk, risk scope for implement, data science like machine learning and AI. So what is the operational risk? Operational risk is defined as, any loss due to, inadequate or failed internal process, people, system, or external events. You see, that is a pretty, broad. It's involved product, process, procedure, people, and like, for example, fraud, natural disaster, legal, they are all operational risk. And it's also very significant risk because most of the companies failed due to operational risk. It's not due to, credit or, market risk. It's most of the company fail actually due to operational risk. So, and the next one is for cybersecurity. So do you think, what about cybersecurity? Cybersecurity it's an independent risk or it's operational risk? Actually, it belongs to the operational risk. Although it's independent, right now it seems like a very independent tier of risk from the operation, but it is operational risk. So with such a big scope, so how can apply data science in operational risk? The following is an example. example is, it's a very general example, but actually I think it's the most important one to implement data science, machine learning, AI, into the risk field. So in the operational risk framework, usually including the six process or six circle, from risk identification to risk assessment analysis to risk measurement to risk management and control, monitor risk management and control, monitoring to reporting and governance and control. The gap is between the top three circle and the bottom three. The top three is more on the control and control and reporting side. It's more close to the first line of business, close to the line of business, following the first line of defense. The bottom three is more close to the risk management function, so it's following the second line of defense. The current operational risk framework is that these two groups are pretty separated. The line of business has their own stuff, a data platform, whatever they do in the control, and the second group, the risk management group, has their own stuff. And these two, at least in the system-wise, of course, people talking to each other, communicating, but in the system-wise, they're not talking to each other. And that's where data science can play a role, and AI and machine learning can play a role to build a bridge between these two groups. So how you build that group, because the data science, involve big data. So when you set big data, you need to collect all various kind of data related to operational risk into one platform, one place, one data lake, one data hub, data platform. So that's the idea. You should bring these two together. Then build some common platform for analytics, for processing, for control. So in that kind of framework, then the first group can, right now the first group has hard time to access the output from the second group, their analytic measurement, how to implement that into their real risk life control. And the second group has hard time to understand how their stuff really implemented in the, risk control, because that's where, the effect, the risk management effect can show, So the gap is due to, the lack of the communication, lack of the, system communication, less kind of, in the big fashion of like data in the AI and the machine learning kind of communication. For example, if I'm a risk manager, I just don't want, don't need, what kind of fancy risk management analysis reports you produced. My simple question is, okay, please show me, certain portfolio within certain period of time. What's their performance? What's their performance? That should be, it should be done by, the new kind of, system and new kind of integrated system. Instead of, you have to submit a request to the risk management group. That the risk management group started to working that and to generate the reports, and then we generate reports and get back to the first line of defense, back to the line of business people. You have to explain them, what's this, what's that. That's the current, but unfortunately, that's the current situation. The second example I could begin the implication is on the cybersecurity side. So this is the IAM, identification and access management. So this is a simple one, but I think it's a very useful one. Each firm, when you hire somebody, they started the organizational relationship starts. You started to, get the system access, get the accounts, get the, use of the, software, hardware. So this kind of provisioning process. So over the years, so for each, employee, so this is accumulated a lot of, provisioning stuff. Many accounts, many products. Then each, periodically, and the management has to review your provisional rights, your provisional resource. So how can data science to help, AI and machine learning help to, relieve the, burden from this management review? So it's a very simple, machine learning implementation. It's, just look at the, the account, look at your access accounts, identify, give them a score. There's two ways. One way is that, you're scoring the access accounts. with a high score means, okay, this accounts, you need it. So that means you don't need the manager to review it because it's high score. That means you really need it. There's no risk to keep it for you. So you just keep it. You don't need the manager to review. For the lower ones that you do have, you need the manager to review it. Probably you don't need it. And there's the second way is, you're doing that significant risk. So if some of that have significant risk, so you have to identify them, use the machine learning model. Then only pick up very few, very significant high-level risk, accounts to give the management to review. And that will relieve the management review a lot, table a lot. So people are saying that what is, machine learning? What is AI? Machine learning and AI, they are just automation right now. So that's one way to think that, what's machine learning, what's AI? They are automation. So basically they are saving the manual, time-consuming manual process, removing those with, smart algorithm and model-based stuff. In the following, I will say something about the, risk management trend and how data science, machine learning models and AI algorithms can be catch this kind of risk management trend or be implemented this kind of, in the risk management trend. This is just some preliminary thinking, because when something is new and then people will be follow that trend and started, think about how to implement fancy stuff like AI and machine learning into this kind of application trends. The first one I can recall we have the GRC trend in the risk management. The GRC trend is like governance, risk management, and control integration. It's called GRC. So this is not really new, but this is going to become a trend for risk management. It's the right direction. Why? Because for any risk management, the output of that or the effective saying the value of the risk management is that how much risk you control, what's the what the effect of the controls you put on the system of people or procedure. Not like how much fancy report. Of course, regulatory reports you need risk risk reports for regulatory stuff. But for business as usual, you need to prove that show your proof that your risk management methodology, process, measurement do show some kind of effect on the company's daily life. Because of this integration, there could be a lot of data, process, and platform integration. And a lot of manual process could be in this. But how do you do efficient integration and automating all this integration and, making a one integrated process, GRC process? The data science and machine learning and AI will be useful in this. The second is, it's that, what you should be careful, why you should be careful to implement these things. So as we already know that data science already be successfully used in many of the, risk management fields, like, credit underwriting I just talked about, and also fraud detection, anti-money laundering, and, other, operational risk management, including legal process. But in the regulatory area, so it's not so fruitful, or it's not so largely applied. Of course, there's a reason, because the reason, I think the most significant reason is that this, AI and machine learning implementation in risk management bringing new risks, bringing its own risks into this risk management. And how to measure, the new risks bringing by this machine learning compared to the classical statistical model. There are new risks bringing to by machine learning and AI models. The reason, classical statistical models are pretty, transparent and easy to explain. It's called, it has very good explainability, stability. All these things are pretty good. But machine learning AI models lack of this kind of transparency, lack of this kind of stability, lack of this kind of explainability. So that kills in the risk. Now how we manage this kind of new risk. So this is the This is the question everybody is asking. Some people started to think deeply into how to resolve, like the explainability. So the AI machine learning explainability is started, to be looked into detail, how to explain the people. Why? Because people think, most of this, like neural network, is like a black box. You have the, input part, you have the process part, you have the output. So that's three components for a model. A model has to have these three parts. But, input, it can be transparent. For machine learning AI models, can be transparent as well as the classical model, as good as the classical model. But it's the middle part, it's the processing part, it's more like a black box. And the output part is also, not as good as the classical model, but that part can be worked out. There's also argument that, we don't need, we don't need the transparency for the black box. As long as we can see, we can work out the input transparency, output transparency, then we don't need the middle of that. I think that argument is a little bit of danger, because, only based on the input transparency, output transparency, and the lacking of the process part, something may happen, but you might not be able to explain it. That's good. But so there's ways to, try to make the middle part, the processing part, more transparent. I think that's the direction should go. We need to have a transparent or comparable, more transparent process on some kind of, multi-process, multi-stage process, and to, decouple the middle part of the process to have a little bit better, explainable process, rather than, stacking it into a black box. So this is revolved to the last part of my talk, how to manage the risk of data science or the AI and the AI algorithms and machine learning models bring into the risk management field. How to, first, as always, you need to identify. So identify the risk, the new risk bringing by AI and machine learning into the risk management field. You need to identify that. So second is, once you identify that, then how do you reduce this risk or mitigate this risk? And currently people focus on various kind of testing. So develop various kind of testing to mitigate these risks. I think that's the initial step. That is the initial step to manage the AI machine learning risk into this into these applications. I think the third thing is that once you have a good sense of how risk this AI machine learning models in your financial modeling applications, then how you mitigate it, So how to control it, put it into control. I think that's the next step. You need first have a policy. For model risk management, you need to have a policy. The policy for AI machine learning models risk management, you need a new policy. I think some firms already started to develop that as a no model risk management policy. I think that's the starting point, but it's not so clear what kind of risk is identified for this AI machine learning in that policy. You need to first the policy, whose responsibility, who is the model developer, is the model user, so who's responsible doing what? Because for machine learning model is heavily depends on the data. So the data is who's responsible for the data. Some people put some firms put IT as the responsible party for data. For sure, IT is involved in the data processing, but data preparing. But who is really understands this data? Who knowing that data has kind of a risk or not? For underwriting, if the data is not comprehensive, complete, sure you're going to be violated the Fair Lending Act. But the IT people knows how to control the regulatory risk like Fair Lending Act. I don't think so. So that kind of corporation responsibility, and that should be put into the policy part. So once you have the policy, then you have to develop procedures to implement those policies. So who's responsible for what to implement these procedures? That the data part I just talked, that's the modeling part, and then the model validation part, model review part. So all this need to be who doing what. So for the sensitivity analysis, like you try to understand the risk of a machine learning model, sensitivity, the stability, who is doing what, the kind of a testing. Is the model review group, model validation group doing this kind of test, or is a joint effort by the model developer and the model validation group? So because of the data scale, for all this model, the model data is huge. So then how we incorporate that, how we incorporate different parties, different departments into a unified kind of a platform instead of separate the platform for this huge data, which could be very non-efficient. So all this need to be defined in the procedure, and this is what I see difficulty, the difficulties, and that also the challenge. The challenge is on the road of implementing data science in the risk management field. So also back here I have a list of this is a focus on the model risk management for apply machine learning AI. Well, here it's called model, but sometimes they call no model, but actually the management for these risks are similar, because you need all these concepts, like a concept you saw needs process verification, inputs, assumptions, output analysis, sensitivity, stability, OPA, like ongoing performance assessment, UAT, user accept test, benchmarking, and backtesting. This is a full list of procedure for the current model, model risk management, SR 11.7 model risk management recommendation. But for no model, for the machine learning models, I see nothing less for these procedures needed, nothing less needed for those things. And also you need to implement new ideas how to execute this kind of a process for machine learning AI, machine learning models, AI algorithms. And, have an equitable algorithm showing to the regulator, your algorithm is equitable, your algorithm is, not biased. There's a lot of things need to do. And I think that is the direction, it's the area we should focus on. Okay, thank you.
Thank you so much for that talk, Colin. It definitely was very insightful, and I really enjoyed it. Unfortunately, we don't have any time for Q&A right now, but I definitely want to encourage everyone to reach out if they do have any questions, and definitely be sure to head on over to our next talk. Pragati Swasthi will discuss technical depth in machine learning systems, so be sure to head on over and check that out. See you all there.